Welcome to the lecture series on 8051 microcontroller. In this lecture, we'll be talking about the branch control instruction set of 8051. Now, they are very important because time and again we'll be using these instructions in our program in 8051. So it is very important to understand them, to learn them, so that we can use them effectively in our program. So basically, all the program branching instructions have been listed here, and basically they can be divided in two categories. Okay, we have got two call instructions here. You could see here two call instructions are there, and rest of them, and there is two return state instruction is there, and rest of them are basically jump instructions. Okay, from here to here. Apart from this one, which is a NOP instruction, rest from here to here are the jump instruction. So we will basically see that jump instructions are basically of two types. Okay, so we have your conditional jump instructions, while the second uh, type is the unconditional jump. Okay, while these uh, four these four AJMP, LJMP, SJMP, and JMP are the are the unconditional jump instructions, and rest of them is JZ, JNZ, JZNE, and uh, DJNZ. These all are the conditional jump instructions. Okay, so how jump instruction is different from a call instruction, and what is RET, return, and return I. So I will talk about it. Okay, so basically this is the unconditional jump, conditional jump, call, and return. Okay, I will talk about these unconditional jump in my next video, because they are a bit important and will take some time uh, uh, to look into them. Okay, so we'll be basically be focusing around the conditional jumps here, and we will before that we'll just see what is the difference between the jump instruction and the call instructions. Okay, so jump instruction, in a jump we simply branch to the new location and continue from there on. Okay, while in call instruction we branch to the new location, which is basically a subroutine. We execute the subroutine, and at the end we return to the main program right at the next instruction after the call instruction. Okay, then while the jump instruction, in a jump instruction there is no intention to return to the previous location. Okay, while while to invoke the subroutine we use call instruction, and to return to the main program we use RET instruction. So there is a intention to go back to the original program using this RET or RETI instruction. We'll see what is the difference between the two after some time. So then the third point is that in jump instruction there is no need to store address, return address, into the stack. Okay, there's no need to store the address. Okay, while in call the return address is pushed into the stack. Okay, that means whatever is there in the program counter is pushed into the stack pointer, and during return the return address is popped from the stack and put back into the program counter. Then the fourth difference is jump can be of three types. It is short or absolute or long, while call is of three types. Call is of two types: absolute or long. Okay, and the fifth difference is that jump can be unconditional or conditional, while call is always unconditional. So this is the basic difference between jump and call. Again we will see what is return and return I. Return and return I. Basically, both of them are used with the call instruction, either your absolute call or long call. Okay, these are not used with the jump instruction. They are used with the call instruction. Okay, so RET, return instruction, is used at the end of ordinary subroutine. Okay, while RETI is used at the end of an ISR, interrupt service routine. We will talk about this in detail in some other lecture. Okay, but just for timing, remember that this is invoked when we are working with the interrupt service routine. Then the second difference is RET simply returns back to the next instruction of the main program, while RETI will not return back to the next instruction of the main program, but will also re-enable the interrupt by making EA bit equals to 1. Okay, so basically what is the operation that happens in RET? So when RET is encountered, so it is pop PC. So whatever there uh, is in stack pointer, okay, it is stored in your PCH and PCL, the higher and the lower bytes of the program counter, and this saves SP -1 and SP is saved with SP -2. While in RETI instruction, apart from these three, EA is also enabled. So EA is made 1. Okay, so this is the basic difference between return uh, and return I instructions. So let's talk about the conditional jumps now. Conditional jumps. Okay, so a conditional jump instruction can have two possible executions depending on the condition. Okay, if condition is true, the program will jump to the program location specified by the label. Okay, we'll see what this sentence means. And if the condition is false, then program will simply proceed to the next instruction. Okay, and please do remember that all conditional jumps are short jump. So 8-bit movement from the point where you are leaving the program. Okay, so we'll start looking at the conditional jumps instruction one by one, and let us start with the first one, which is DJNZ. Okay, so we will look into it, how it is used. The syntax is R comma R address. Okay, so what it means, let's see. This is the syntax. So if I take an example, DJNZ, R is basically any of the general purpose register. So it could be either R0 to R7, any one of them. Let me take it R7 comma back is the label. Okay, so let's see what is happening here. So basically this instruction is used by the programmer to create loops. Okay, we initialize the loop count in some register like R7 I have taken here, so some value is set here, which is basically the count. Now at the end of the loop we write the instruction, this instruction. Okay, back is the label where we wish to bring the begin the loop from. Okay, this back is the label where we wish to begin the loop from. So what will happen, this instruction will first decrement R7. Okay, then it will check whether R7 has become equal to 0 or not. If R7 is not 0, okay, then program will jump to the location back, this back, it will jump to back, and this will go on happening till R7 finally becomes 0. Okay, and that's when the loop will break and program will simply proceed to the next instruction. The count could have been in any register from R0 to R7. Okay, I've used R7, but it could any register R0 to R7. And please make it clear also that whatever is the count, we get the exact number of iterations. So if I am saving say 6 in R7, we will get 6 iterations. If I am saving 5, then I give 5 iterations, not one more, not one less. So this is the DJNZ instruction. Let me illustrate it with the help of an example. Let me take an example of DJNZ instruction. Okay, so I'm writing here move R7. I have taken R7 hash some number 25h say. Okay, then I'm writing the label. What is the label that I have taken? I have taken back, so I'm writing back here, BACK, back. Okay, then I am writing DJNZ and R7 comma back. Okay, so what will happen? So first of all, 8051 will execute this instruction and it will save value 25. Okay, 25 is in hex. Okay, so if you want to have an idea of what exactly is this number, you should convert it into decimal. Okay, so R7 will be saved with the value 25h. Okay, and then in the next instruction it will first decrement R7. Decrement R7 means now R7 becomes 24. Then it will check whether R7 is 0 or not. It is not 0. Then it will move to back. Back means it will come again to this instruction. Again it will decrement R7. Now it will become 23. Then it will check whether it is 0 or not. No, it is not 0. Then again it will go to back. And this process of iteration will go on how many times? 25h times. 25h times. And finally when R7 after decrement it becomes equal to 0, then the control will move forward. Okay, so this is normally employed to provide some software delay in 8051. I hope it is clear. Also please remember that in place of R7, sorry, in place of R7 I could have any address also. Okay, I could have any address here also, like say it could be 35h. So 35h is a memory location address, so we can have this type of sorry, not here, here in place of R7 it could be 35h. So whatever is there in 35 will go on decrementing until it reaches the value 0, and then the program will proceed. Okay, let me take another instruction which is your JZ. Okay, so JZ, and it is followed by a relative address. Normally it is a label. Okay, so JZR address, relative address. So this is your the syntax. So I may write it down as JZ any label. Say I'm writing down. Okay, so jump if a is 0. Jump if a is 0. So when a equals to 0, then the jump will happen. Otherwise this instruction will go on evaluating. Okay, so let me take an example so that it becomes more clear, and I will take that example in the next video because 15 minutes is over for this video. Okay, thank you.